So we know why variability is important, how we determine that variability with productivity maps. Then we're going to see how we actually use those productivity maps. And first, let's see if there are any questions. If you have any questions, please let us know now, and we'll be happy to address them or later. So using productivity maps. Now these are the main groups of applications. First is an excellent tool for directed sampling to see where to focus. So selecting soil sampling points or sample sites for leaf sampling, moisture probe points, deciding where to dig soil profile pits. So everything that's you want to focus on the field, it's an excellent tool for that. The next step will be characterizing management zones, which is to identify the limiting factor. This can take form of a soil lab, it can take form of just a field evaluation to see if there are any drainage issues, or you can evaluate just one factor, just like pH, like we're doing in some areas where pH is the issue, then they just go and measure pH across zones. So that depends on the region and on your criteria, what are you going to use to characterize, but you need to characterize to see what are the limiting factors on those zones. Once you have done that, the next step is to optimize use of crop inputs. It could be site-specific, seed applications, and you'll see the difference between variable and fixed rate, but always site-specific because you're taking into account those management zones, either seed applications or fertilizer applications. What we see in most markets is that fertilizer applications are the most immediate application type of use, and seed application, especially in corn seed, which is very expensive, also has a great potential for profit. So those are the two main crop inputs that will be regulating according to the site-specific criteria. And then, of course, addressing irrigation, drainage issues, focusing on the drainage system and points. So these are some slides that illustrate that. Field validation, it can be a general field validation, which is to go with a tablet, a PC, a notebook, or a smartphone to the field with your productivity map, see where you are, and then correlate the productivity maps with possible field issues. Just go there and see if there are any drainage issues or irrigation issues or other types of issues. Just go into the field with the field map, with the productivity map, and making a quick evaluation. It's a key activity for characterizing the zones. You could make some directed samples or to characterize zones, not necessarily soil labs, maybe some physical characteristics. So that depends on the agronomist criteria, but it's a very good tool to define which locations, as you can see here in this map, in red are the points that were visited to characterize those zones. Or this is a method that Francis will go in more detail that we're using in GeoAgro-Africa, which is based on the productivity map, define general zones. And on those general zones, define something similar to a grid sampling pattern where we'll do a composite sample for each zone. So we have one sample that will characterize this zone in the left. As you can see, it's divided by a red line. And a number of samples which are composite into a single sample, which will characterize this zone in the right. And this has been an effective, cost-effective, and reduces time and cost to diagnose the causes of variability, this type of approach. Next, once we have characterized the zones, we'll think about management decisions. So there are a number of decisions that we can make. We'll analyze alternatives, priorities, make decisions on seed variety and density, phosphorus, nitrogen, other nutrients. We'll also take into account the seed fertilizer prices. We'll see the nitrogen response curve and see if it's worthwhile or what is the economic best decision. Other inputs, production costs, the extraction of the nutrients based on past season. Based on those zones, on those zone characterization where we find what are the limiting factors, we can do we can take macro management decisions where no variable rate technology is required, where we just divide the field. So if there's no variable rate equipment, we can make just an approximate division of the zones, in this case in 3 zones. In this case is a corn crop in the 2009 in Buenos Aires. In this case, based on the characterization, the decisions that were made were a seed. There was a 20% less density in lower yielding areas that led to a $72 per hectare saving. PDA, there was a savings in 50 kilograms, and urea an 80 kilogram savings, which in total was a total savings of $137 per hectare without affecting the yields. So basically, the macro management decisions involve dividing the fields in broad areas, and then based on that, we'll adopt a crop rotation strategy. Maybe there will be different crops grown, fertilizing strategy, hybrid selection, seeding dates, drainage, or irrigation management based on those broad zones. Then we come to micromanagement decisions, where we need to create prescription maps for variable rate applications and optimize inputs according to the field potential. So here you see in this, again, crop season corn 2009. Here you see based on the productivity maps, 3 zones were defined: low, mid-mound, and mound. So there was an input savings in seeds of $49, and also there were increasing yields of $245 with a total benefit of $293 per hectare. So based on the zones, different goals were set. So low areas with hydro risk, 60,000, half mounds, 72,000, sandy mounds, 50,000. So an extra 1,700 kilograms per hectare yield was achieved in zones with supposedly less potential. So I'm not going into much detail, but basically it's a matter of making informed decisions based on the response curves, either in seed or fertilizer, and then have savings in those crop inputs or have higher yields, and that amounts to the total. So here we have 137, here we have 283, but that varies, and it's always a good idea to measure that against a typical management. It can vary anywhere from $30 to $300 per hectare based on our experience, that type of savings.